Assalamu alaikum. This is me, MD Robiul Islam from Uttara University, Department of Electrical and Electronics Engineering, Batch 27B, Evening. Here, my two group member, MD Motiur Rahman and MD Alamin. Today, I presenting a tutorial about learning SBM and application for higher accurate classification. A classifier derivated from statistical learning theory by Vapnik et al. In 1992. Okay. In this tutorial, we discuss some basic part of SBM like support vector machine, support vector, hyperplane, margin, linear SBM, nonlinear SBM, some equation of SBM, SBM classification by using MATLAB. Okay, now we discuss what is SBM. The full form of SBM is support vector machine. Support vector machine is a supervised machine learning algorithm which can be used for both classification or regression challenges. However, it is mostly used in classification problem like this image. SBM are based on idea to finding a hyperplane that based a divided dataset to classes as shown as this image. Okay. Support vectors. Support vectors are the data point which are closed to the hyperplane. Suppose this is a dataset and this is a dataset. Suppose this is positive dataset and this is negative dataset. If we consider this is a hyperplane, in this time this data point and this data point and this data point is nearest from the hyperplane. So we can say this is positive support vector and this data point is nearest from the hyperplane. So we can say this is negative support vectors. Hyperplane. A hyperplane is a direction plane which separate between a set of objects having different classes membership. As a simple example, for a classification task with only two features like the image above, we can think hyperplane as a line like this straight line that linearly separate or classify data. Suppose this is a data set and this is a data set and classify this straight line. So we can consider this is a hyperplane. In two-dimensional view, hyperplane is a line, but in three-dimensional view, hyperplane is a surface. Margin. A margin is a gap between two lines on the closest classes point. Okay. If you consider this is positive data set and this is negative data set, and this is a hyperplane. This negative data and this positive data is nearest from the hyperplane. So we can consider margin difference between this positive support vector and negative support vector. Linear SBM. Linear SBM is used for linearly separate data, which means if a dataset can be classified into two classes by using a single straight line, then such data is termed as linearly separable data and classifier is used called as linear SBM classifier. So as it is two-dimensional, space, so we just using a state line we can easily separate those two classes like this image.
Assalamu alaikum. I am Alamin. Nonlinear SVM. Nonlinear SVM is used for nonlinearly separated data, which means if a dataset cannot be classified by using a straight line, then such data is termed as nonlinear data, and classifier used is called as nonlinear SVM classifier. If data is linearly arranged, that we can separate it by using a straight line. But for nonlinear data, we cannot draw a single straight line. Consider the below image. Nonlinear SVM. So to separate these data points, we need to add one more dimension. For linear data, we have used two dimensions x and y. So for nonlinear data, we will add a third dimension z. It can be calculated as z is equal x square plus y square. By adding the third dimension, the simple space will become as below image. So now SVM will divide the dataset into classes in the following way. Consider the below image. Since we are in 3D space, hence it is looking like a plane parallel to the x-axis. If we convert it in 2D space with z equal 1, that it will become as. Formulation of SVM. Integrating the constant in Lagrangian form, we get minimize j of w alpha equal half w to the power t w minus summation of upper limit and lower limit I equal 1 alpha edi into w to the power t xi plus b plus summation of upper limit and lower limit I equal 1 alpha I, subject to alpha I greater than n equal 0 ai. Method of Lagrange multipliers states that j is minimized for w and b as before, but it has to be maximized for alpha. The point that j represents is called a saddle point. The function j currently is represented in its primal form. We can convert it into its dual form for the solution. J of w b alpha equal half w to the power t w minus summation of upper limit and lower limit I equal 1 alpha I di into summation of w to the power t xi plus b plus summation of upper limit and lower limit I equal 1 alpha I. At the optimum, del j by del w equal 0 and del j by del b equal 0. Now w0 equal summation of upper limit and lower limit I equal 1 alpha I di xi, and summation of upper limit and lower limit I equal 1 alpha I di equal 0. Build a simple support vector machine using MATLAB. Load the sample data. Load data name. Create data a 2-column matrix containing sepal length and sepal width measurements for 150 iris. From the species vector, create a new column vector groups to classify data into two groups, data and non-data. Like this code. Randomly select training and test sets. Like this code. Train an SVM classifier using a linear kernel function and plot the group data. Like this code. If we implement this code in MATLAB, we found this figure. Add a title to the plot using the kernel function field from the SVM structure as the title. Now add the code with previous code and found this figure. Use the SVM classify function to classify test set. Now add the code with previous code and found this figure.
Assalamu alaikum. I am Moti Rahman. Now I talk about 10 SVM classifier using a Gaussian kernel. This example shows how to generate a online classifier with Gaussian kernel function. First, generate one class of points inside the unit disk in 2 dimensions, and another class of points in the annuals from radius 1 to radius 2. Then generates a classifier based on the data with the Gaussian radial basis function kernel. Other kernel functions might not work with this state box constant, since they might be unable to provide a state classification. Even though the RBF classifier can separate the classes, the result can be overtrained. Generate 100 points uniformly distributed in the unit disk. To do so, generate a radius r as the square root of a uniform random variable. Generate an angle t uniformly in of 0 to pi and put the point at r cos t, r sin t, like this code. Generate 100 points uniformly distributed in the annuals. The radius is again 4, like this code. Plot the points and plot circles of ready 1 and 2 for compression, like this code, and we found this boundary.
That's all for today. Thank you.